Hello my dear students, welcome back to the one more session class on Fourier series. Today we will see one more problem on Fourier series only when the given intervals are from 0 to 2 pi. In today's class we will see the limits when it's given in if they have given you to find the Fourier series for the given function when the interval from 0 to 2 pi. The procedure will be same which we have seen in the previous classes. The method, the steps are same. Just only here it's going to change, the function it's going to change and your limits are going to change. So the problem, find a Fourier series to represent f of x is equals to x square in the interval 0 to 2 pi. Now what's your function here? Your given function is x square and intervals from 0 to 2 pi. Now here you have to find a0, an and bn. First we will write the Fourier series formula. F of x is equals to a0 by 2 plus summation n is equals to 1 to infinity an into cos nx plus bn sin nx. Will mark this is equals to equation number 1. Here given, here f of x is equals to x square, and here you are not going to check whether the given function is even or odd function because your interval from 0 to 2 pi. When you are going to check when the given function is even or odd, when it is given in the form of minus a to a. Suppose if they have given you from 0 to 2 pi, instead of from 0 to 2 pi, if they have given you from minus pi to pi or minus 2 pi to 2 pi, then in that case you have to check whether the given function is even or odd. But here the given intervals are from 0 to 2 pi, so no need of checking. Just we will move for finding the values for a0, an and bn. First we will move for finding the a0. To find a0. What's the a0 formula? A0 is equals to 1 by pi integrating 0 to 2 pi f of x into dx is equals to 1 by pi integrating 0 to pi. What's your f of x? X square into dx. Now what you're going to get when you're going to do the integration, which formula you're going to use? X to the power of n is equals to x to the power of n plus 1 divided by n plus 1, which is the basic formula for the integration. So it's x to the power of 3 by 3. Limits from 0 to 2 pi. Substitute your upper limit minus lower limit. 1 by pi of 2 pi whole cube by 3 minus 0. It's equals to 1 by pi of 8 pi cube by 3. So from here we can cancel 1 pi. So what's your a0 value? A0 is equals to 8 pi square by 3 is your a0 value. Now we will move for finding the next value, an value. To find an is equals to n is equals to 1 by pi integrating 0 to pi f of x into cos nx into dx. It's equals to 1 by pi integrating 0 to pi. F of x is equals to what? X square into cos nx into dx. Here which formula you have to utilize? In the previous classes I said you, which one you have to utilize? You are going to use your Bernoulli's integration by part, that is uv into dx is equals to uv1 minus u dash v2 plus u double dash v3 plus alternative no, minus u triple dash v4 plus so on. And what I said, every time you are going to consider the function under u and your trigonometric part under v. So here we will take u, it's equals to x square and v is equals to cos nx. U dash, it's equals to 2x. U double dash, it's equals to 2. U triple dash, it's equals to 0. What you are doing? You are doing the differentiation. Next what you have to do? V stands for integration. V1, it's equals to integration of cos, it's a sine nx by n. V2, it's equals to sine integration. V2 is what? Double time integration. So already one time it's got over. Now you have to do the integration for sine. Sine integration is minus cos nx by n square. Now V3, it's equals to minus sine nx by n cube. So on it will be. We will substitute all the values in the formula. What you are going to get? an is equals to 1 by pi of u is equals to x square, v value is equals to sine nx by n, then minus u dash value is equals to 2x and v2 is equals to minus cos nx by n square. Next plus u double dash value is equals to 2 and your v3 is equals to minus sine nx by n cube and your limits from 0 to 2 pi. Now you have to substitute your upper value and lower value, where your sine n 2 pi value is equals to what? Since we know that since sine n 2 pi value is equals to 0 and cos n 2 pi value is equals to 1. Now substitute those values, where your first term and the last term vanish by using this value, where sine 0 is equals to what? Sine 0 is 0. So this and this will get vanish. An left with this minus and this minus. It will become plus 1 by pi of 2x into cos nx by n square and limits from 0 to 2 pi. It's equals to 1 by pi of 2 into 2 pi by n square cos n 2 pi, where minus 2 into 0. Cos 0 value is equals to 1, but here outside is also 0, so that term will become completely 0. It's equals to 1 by pi of 4 pi by n square into 1, where since cos n 2 pi value is equals to 1, so your an it's equals to 1 by pi into 4 pi by n square, where pi and pi it's got cancelled. An is equals to 4 by n square. Your an value is equals to what? 4 by n square. Now similar, we will go for finding the bn also. to find Bn, where Bn formula is what? Bn is equals to Bn is equals to 1 by pi integrating from 0 to 2 pi f of x into sine nx into dx is equals to 1 by pi of 1 by pi integrating 0 to 2 pi. Substitute your given function x square into sine nx into dx. Again use Bernoulli's integration by parts is equals to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus so on. Here u is equals to x square, u dash is equals to 2x, u double dash it's equals to 2, u triple dash is equals to 0, v is equals to sine nx, where sine integration it's minus cos nx by n, v2 it's equals to minus sine nx by n square, v3 it's equals to minus into minus, it's going to be plus cos nx by n cube, so on. Now substitute all the values into the formula. Bn it's equals to 1 by pi integrating 0 to substitute now. Bn it's equals to 1 by pi of u is equals to x square, v1 is equals to minus cos nx by n minus u dash it's equals to 2x, v2 is equals to minus sine nx by n square, then plus u double dash value is equals to 2, v triple dash is equals to cos nx by n cube. Your limits from 0 to 2 pi. Since we know the values, since sine 2n pi value is equals to 0, cos 2n pi value is equals to 1, and sine 0 it's equals to 0, cos 0 is equals to 1. Now we will substitute. See, your sine term will get vanished. We are left with cos terms. It's equals to 1 by pi of x square minus cos nx by n, then plus 2 into cos nx by n cube, limits from 0 to 2 pi. Now substitute the values. Bn is equals to 1 by pi of 2 pi whole square into, where we will keep minus, this minus outside, then cos 2n pi by n plus 2 into cos 2n pi by n cube, then lower limit minus 0, it's going to be 0, then plus 2 into cos 0 by n cube. Bn it's equals to 1 by pi of minus 4 pi square by n into cos n pi value is equals to 1, then plus 2 into cos 2n pi value is equals to 1 by n cube minus n2 by n cube. So this and this will get cancelled. Bn is equals to 1 by pi of minus 4 pi square by n. So this and this term will get cancelled. Bn is equals to minus 4 by n. The value of Bn is equals to what? Minus 4 pi by n. Now we will substitute all these values into your equation number 1 where you have written your Fourier series. Substituting a naught, a n and b n values in equation number 1, f of x is equals to, where a naught value what we got, 8 pi square by 2 into 3, then plus summation n is equals to 1 to infinity, 1 to infinity, a n value is equals to 4 by n square, 4 by n square into cos nx, then plus bn value. What is your bn value? It's a minus 4 pi by n into sin nx, where this and with this will get cancelled, left with 4. F of x is equals to x square, it's equals to 4 pi square by 3, and where even this 4 we can take as common, we can write completely common, plus 4 summation n is equals to 1 to infinity cos nx by n square minus pi into sin nx by n. If you want, still you can simplify completely. 4 you can take common and you can write as, if you are going to take completely common which term? 4 is common here. If I am going to take 4 completely out, it's going to be pi square by 3 plus summation n is equals to 1 to infinity cos nx by n square minus pi into sin nx by n, which is the required Fourier series for the given function. If you are having any kind of a doubt regarding this problem, you can ask me in the comment box. If you are new on this page, if you liked my way of explanation, if you got each and every step clearly, then please like the like button and subscribe it. And do not forget to share this video among your friends who need the help to get the mathematics subject easily. Thank you so much for listening me. We will meet in the next session class with the new problems based on some other different limits, or we'll see the problems based on opening the series. Till now we have seen how to represent the given function into the Fourier series. In next class we will see for opening the series. Thank you once again.